In our previous video, we learned how to test for normality in spss. That's the procedure for testing for normality. So in this video, we're gonna learn how to interpret the results using the numerical method and the graphical method. Alright, so for the numerical method, like I said in the last video, we use the z-score and the Shapley-Wilk test to interpret our normality test. So using the z-score for skewness and kurtosis, you can find it from the descriptive table here, and then we'll check for the kurtosis and the skewness for both male and female. That is for each group of the dependent variable. Alright, so we'll start with that of the male. If the engagement is normally distributed among the male participants. So the z-score to calculate the z-score for skewness is z-score equals to skewness all over the standard error. Alright, so as you can see here, our skewness is minus 2.118, while the standard error is 0.687. So minus 2.118 divided by 0.687. But before that, you should have it at the back of your mind that if your z-score is within plus or minus 2.58, this means your dependent variable is normally distributed among the independent variable. But if they exceed, if they don't fall within plus or minus 2.58, it means your dependent variable is not normally distributed. Alright, so when you calculate minus 2.118 divided by 0.687, we will get 3.082. 3.082 exceeds plus or minus 2.58. Okay, so now we calculate the z-score for kurtosis. 5.459 divided by 1.334, and our result is 4.092. That is minus 4.092. That of skewness is minus 3.082. Then that of kurtosis is 4.092. So now you see that the engagement scores is not normally distributed among the male participants. So there is no normality here. So we check for female, the engagement scores among female. So we have the skewness here, which is minus 1.366, and we have a standard error of 0.687. So we have the z-score for skewness, which will be minus 1.988. This falls within plus or minus 2.58. And then the kurtosis, we have 1.863 divided by 1.334. And we'll get, if you calculate this, we'll have 1.396. So the z-score for kurtosis also falls within plus or minus 2.58. So it means the engagement score, which is the dependent variable, is normally distributed among the female participant, but it's not normally distributed among the male participants. So if you are to carry out a one-way ANOVA or a t-test, independent samples t-test, this has violated the assumption, because once the dependent variable is not normally distributed among just one group of the independent variable, then the assumption has been violated. Alright, so now explaining the results using the Shapiro-Wilks test. The Shapiro-Wilks test states that if the significant value, the significant value is greater than 0.05, it means the dependent variable is normally distributed. But if it is less than 0.05, it is not normally distributed. Okay, so now from this Shapiro-Wilks results, we can see that significant value is 0.005. So it's giving us the same results with that of the z-score for skewness and ketosis. So it's still telling us that, oh, this is not normally distributed among the male participants. Then for the significant value for the female participants, we have 0.108. This is greater than 0.05. So it means the engagement score is normally distributed among the female participants, just like what the z-score has given us. So it means our answer is correct. Alright, so using the graphical method, the visual graphical method, you can also see by visual inspection that this dependent variable is not normally distributed among the independent variable of male and female. So this is how we interpret these results. For more videos on tutorials on SPSS, subscribe, share, comment, like. Thank you.